I'm D. Lakshmi, working as an Associate Professor in the Department of CSE, Panimala Institute of Technology. Now I am going to explain the concept of virtual memory. Here, why we are going for virtual memory? Actually, this concept comes in the operating system. It is a storage allocation technique. Virtual memory is nothing but a storage allocation technique or scheme used by OS. It is a storage allocation technique used by OS. Now the OS, when it goes for virtual memory is also called as a logical memory or imaginary memory. So we don't have a separate memory as physically available in the system. It is going to act like a original memory or actual memory. It gives us the impression that as if the system is working with the original memory. Why the OS goes for this virtual memory? When the program size is larger than the RAM size available, then the OS follows this storage allocation scheme known as virtual memory. Let us take a program example. We are going to execute a program sample.c. Okay. So this program size is very larger, which cannot be executed since the RAM size is small. So what happens? The OS is going to get a memory from the hard disk as the virtual memory. So this virtual memory is shown here separately. So it takes the available memory from the system itself and it is going to act as a virtual memory. Here in this virtual memory, the program data and instructions will be kept inside, and this memory can be splitted as equal number of or equal sized blocks. This memory is going to be partitioned into equal sized blocks, and each block is identified as pages. So we can name the pages as page 0, page 1, page 2. It goes up to n number of pages. Now what is the size of the page? Each and every page is going to have the is vary with the powers of 2. 2 power 0 means 1. So the size of the page is going to be 1 KB. 2 power 2 means each and every page size is going to be 4 KB. So it varies always, the page size varies in powers of 2. In this way, the given data in the program is split into number of pages. So each and every block or page is going to have the same size. Now, whenever the program is to be executed, the page must be brought into RAM memory. Why? Because the CPU is capable of accessing the data only from the main memory or RAM. Since the space is not available, the data are kept in a virtual memory. When that data are required, it is present in the form of pages, and these pages will be moved into the RAM memory when it is required. So this concept is called as virtual memory. Even though the program size is larger than the available physical memory, we can execute the program without any error or without any disturbance or without any difficulties by means of having the virtual memory concept. So virtual memory leads to execute the program. Available physical memory it is going to utilize, and it is going to act as a separate memory, and it gives us the impression that we are working with the normal physical memory as if it is going to have the number of pages. In similar way, the available RAM space is also partitioned into number of blocks. So here these blocks are called as pages. When the available RAM spaces are partitioned into number of blocks, it is called as frames. Now the page size and frame size are going to be equal. Always page size is equal to frame size. In order to fit a page into the RAM, the page size and frame size must be equal. If I take each and every page as 4 KB of size, each and every frame in RAM is also of size 4 KB. So a page can fit into a frame of RAM. In this way, the required data will be present as pages, and it is moved to the RAM memory or main memory as frames. So in order to maintain this mapping, it is going to generate the addresses for each and every frames. Those addresses are known as logical addresses. The actual addresses of RAM are called as physical addresses, and the created addresses for virtual memory are called as logical addresses or virtual addresses. So logical addresses or virtual addresses are present for VM, and physical addresses will be available actually for RAM memory. Okay. So whenever we want to move the page to a frame, page to RAM, now this logical address will be converted to physical address, corresponding physical address. So this translation of given logical address into physical address is called as memory mapping technique. This address translation is done by means of an hardware known as memory management unit. So this memory management unit is going to have the available free space data in it, so that it can convert the given logical address into physical addresses. In this way, the virtual memory concept is followed, and it is made the user to execute a large programs at the same time, even though the size of the program is larger than the available physical memory. That's all about the virtual memory concept.